Today I'm here to teach the chemical concept of partial hydrogenation of triglycerides. By the end of this informative video, you will have a good understanding of the process of hydrogenation of unsaturated fats, also referred to as triglycerides. You will also be able to answer these three questions. What is the process called that allows us to use vegetable oils in solid food substances? Number 2, what is the difference between hydrogenation and partial hydrogenation? And finally, I'm going to have you be thinking about why trans fats are not good for you and which popular food items uses partial hydrogenation in processing them. An unsaturated triglyceride is determined by its double bonds between carbons. These double bonds create a weaker carbon chain, and there is a higher capability of the chain coiling and breaking. This also lends to the fact that unsaturated fats, which are triglycerides with 2 or more fatty acid chains that each contain 1 or more double bonds, have melting points below room temperature and are liquid at room temperature. Way back in the early 1900s, it was discovered that vegetable oils could be substituted for animal fats such as butter by making a product known as margarine. There are many popular foods today that rely on vegetable oils for their production. Vegetable oils may be converted to solids by the process of a hydrogenation reaction. The goal of hydrogenation is to optimize the balance between hydrogen consumption and product value to keep food processing costs low. We start with an unsaturated fatty acid, introduce a catalyst of H2 and high heat. In this chemical reaction, the addition of hydrogen is pumped into liquid oil at high temperatures. The oil is mixed with tiny metal particles, usually platinum or nickel oxide, as the catalyst. Through this process, double bonds are broken and the cis fatty acids, which are alkenes, double bonded, are converted to trans fatty acids, which are alkanes, single bonded, saturated. This also stands for transformed fatty acids. The degree of hydrogenation of unsaturated oils controls the final consistency of the products. When there is a limited amount of H2, only some of the double bonds are broken between carbon-carbon molecules, thus creating partial hydrogenation. And in contrast, for complete hydrogenation, this reaction happens when enough H2 is supplied to break all the double bonds, therefore turning the unsaturated triglyceride into a saturated triglyceride. Look what would happen by taking America's favorite cookie if we simply took vegetable oil, added some powdered sugar, and attempted to create a delicious cream-filled cookie. Not very appetizing. When unsaturated fatty acids are altered by partial hydrogenation, they are converted to saturated fatty acids, which have the effect of straightening the molecular chains and changing the physical properties. Also during partial hydrogenation, some of the unsaturated fatty acids, which are normally found as the cis isomer about the double bonds, are changed to a trans double bond and remained unsaturated. These trans fatty acids differ from cis fatty acids in that they are now shaped in a more linear form as opposed to the bent forms of cis isomers. Most trans fatty acids, although chemically still unsaturated, produced by the partial hydrogenation process, are now classified in the same category as saturated fats. The benefits of trans fats as they relate to the hydrogenation process is that they are inexpensive and have a long shelf life. The negative factor is that hydrogenated foods that contain trans fatty acids tend to raise the bad LDL cholesterol while they lower the good HDL cholesterol. They are considered poisonous to our bodies as they interfere with the metabolic process of life, by taking the place of a natural substance that performs a critical function. Our bodies have no defense against them because they did not exist 2 billion years ago, so humans have never had the need to evolve a defense against them. In closing, let's refer back to our original 3 questions. The answer to question number 1 is complete hydrogenation and partial hydrogenation. The answer to number 2 is in hydrogenation, all of the double bonds are broken and converted into single bonds, as compared to limited amounts of hydrogen added to control the amounts of double bonds converted to single bonds, which creates a partial hydrogenation. The answer to question 3 has many possibilities, but my favorite example is an Oreo cookie.